in Chapter 12. Chapter 12 should have given you an introduction to the nervous system, and one of the things that it should have done is give you an idea of what those cells are going to look like and how those cells are going to transfer information. Hopefully that's where the professor ended in part 1. One of the things that we have to remember about the nervous system. The nervous system is going to contain what we know as our central nervous system and our peripheral nervous system. Did they happen to get to that point in part 1? Distinguishing between the central and the peripheral. Which one, what are the components of the central nervous system? The brain, my spinal cord. Okay, well, when we think about the nervous system, isn't that kind of what we think about? I mean, somebody says, oh, you're getting on my last nerve. Okay? Isn't that sort of what we think about? The brain and the spinal cord? Well, yeah, that's our central nervous system. But see, now we've got to kind of break it down, okay? Because we've got to understand we've got that central nervous system, we've got the peripheral nervous system, and then the other part that this chapter is going to get into is going to be the peripheral nervous system. What does it mean when you say periphery?
Outside.
Outside. To the outside. Outside of what?
I'm saying outside of brain and spinal cord.
Outside of my central nervous system. That brain and spinal cord. On this model, right here, can everybody kind of see my brain and my spinal cord? Okay? See how it looks like? It's got all these strings that are exiting out. Okay? Can everybody kind of see that? Alright? Everybody got that? Yeah? That's my peripheral. These are going to be the nerves that exit the vertebral column. That's what we've got to think about. We need the spinal cord for conduction. Conduction. Information. Now let's think about this for a second. Information needs to go up and down the spinal cord. What? What does that mean? When I say it's got to go up and down.
Brain processes input and output. Brain
Process. Brain's got to process it. We got to have a way for it to go. We got to need to have transmission. Yes. Well, wait a minute. Where does information come from? Sensors. That's pretty good. What's my sensory information?
Sight, sound.
Sight, sound, taste, smell, hearing, touch, and guess what? Got another one. Equilibrium. Yeah, kind of cool, okay? So that means all of this information, not just out here when I think about this peripheral system, but I got to think about the peripheral system in my body outside of that spinal cord, outside that central nervous system, and I got to make sure information can move into my central nervous system, that it can be processed, and that I can get a response out. I need to make sure that this is going to happen. Fibers of this system are going to allow that to happen. I'm going to be able to get the information in, like for example, right now, that light for the LCD almost blinds me. It is so bright to the point that when I'm standing, like right here, trying to talk to y'all, it actually hurts. That's how bright that light is. It actually makes my brain think there is pain from the light. Kind of cool, right? Not necessarily cool, but cool. Okay? The information that goes in, it's got to be integrated. Now here's the thing. Every piece of information that right now, for example, that we're sitting here, we're dealing with temperature, we're dealing with sound, we're dealing with smell, we're dealing with light, you're dealing with touch as you're sitting in these chairs, okay, as you're writing on the paper, all right. Does every piece of that information need to be processed in the brain? No. Okay? Some information can be processed at the level of the spinal cord where it enters. Writing actually is going to be kind of cool, because writing, it requires that you use higher order brain skills. So that is actually going to involve the brain, the spinal cord, the skeletal muscle. I mean, it's got all this stuff for the writing. But right now, as you're sitting here in the chair, all right, did you happen to feel the chair on your butt when I said something? Nah. Okay? A lot of that's just right there at the level of the spinal cord. Okay, you've got muscles that are being controlled to act on making sure that you stay upright in the chair and don't fall over. Just say. Most of your reflexes. Reflexes, for the most part, they're just going to be right there at the spinal cord. Locomotion. For example, walking. And it was so funny. On the radio this morning, coming in, they were talking about how babies learn to start walking. Do you all remember learning how to walk? You remember it?
No, my 11-month-old is going through that right now.
Okay.
She's learning how to walk.
Do you ever wonder if that's why diapers are thick?
If that's why they're thick. I thought it was good fit.
I've often wondered if the diapers are thick,
They fall.
so they have padding when they fall.
Yeah, it could. It didn't go very far. It fall, so.
Yeah. So this is true. We're not going to go there. Okay. So, we needed to coordinate activities. All right. Not just walking. Okay. But it's really cool how we do learn how to walk and don't remember it. I don't remember it. Now, reflexes. This is stuff, even though when we look at the skeletal muscular system, with the skeletal muscular system, we say that it's voluntary, that it's under control, okay? The one part of that skeletal muscular system that isn't is reflexes. Reflexes. You're at the doctor's office. You're sitting up there, and I don't know, they're going to go through and do like the general physical exam. You're just kind of sitting there, and they'll come up and they'll on your knee with that little hammer. Okay, you're talking to love all the stuff they do, see? What happened? Boom. Did that kick happen? Could you even think about it happening quick enough for no? Because with the reflexes, when we think about the reflexes, that's going to be occurring at the level of the spinal cord where the stimulus enters. So, for that knee-jerk reaction that happens, it's actually coming in at about these levels, and that's where it's getting processed. The response is given before the brain even registers it, which is kind of cool.
Is that still true for reflexes, like pupillary response, where it's actually closer to the brain than the spinal cord?
Now, one of the other things that we look at with the nervous system, we have those lovely cranial nerves. You guys remember those? Okay? Those are nerves that are to our, for the most part, special senses. They're going to our sight, smell, taste, sound, equilibrium. So their responses, they still call it a reflex. They just refer to it as a cranial nerve reflex.
When your brother has one, it's like we want to walk and we can't.
Yes. When we, a lot of times when we hear a diagnosis, okay? Like for example, hyperthyroidism, multiple sclerosis, all right? Usually the best thing to do, take the terms apart. So, multiple sclerosis. Well, okay, I kind of know what multiple means, all right? Well, what does sclerosis mean? Any idea? I'm sure you've all heard of multiple sclerosis, right? Okay? But do you really know what that term means? No. That's because I just love how they like to throw stuff out there at us. And, you know, most of the time, you know, our idea is, okay, let's just take it at face value. No. Never do that with anything. Okay? Look up everything. Sclerose means that it's the breaking down, and in this case, of the nerve tissue, the fiber, the different myelin, the coverings, the wrapping of the nerve cells. Now, here's the thing, okay? When we talk about a nerve cell, for the most part, this is our idea of a nerve cell. Got the nerve.